in this lockdown time you would be doing great at your home and you would be having great health. Okay, now in this video we are going to discuss the further part of differentiability. In the previous one we have discussed the concept of differentiability. We have seen 2 to 3 problems on that concept. Now the next part of this differentiability, that is we have to see the relationship between continuity and differentiability. So see, if any function is derivable, for example, let's take any function and that function is differentiable at that particular point, that means that function is going to be continuous as well. इसका मतलब ये है कि अगर कोई भी function differentiable है किसी point पे, that means it has to be continuous. वो continuous होगा तभी वो differentiable हो पा रहा है. So a function is derivable at point A, then it is continuous at point A also. So we know f dash of A from the basic first principle method, or this is the basic of differentiation. From this expression we say whether the function is differentiable or not. So we'll prove that if a function is differentiable, then it is continuous as well. So we'll take this expression f of a plus h minus f of a. Now what I am going to do, I am going to multiply and divide this expression by h. F of a plus h minus f of a divided by h into h. Now take the limit on both the side. So limit h tends to 0. Now I'll take limit, in this case h tends to 0. Now you can see this expression is forming, this is nothing but the definition of differentiation. So limit h tends to 0, f of a plus h minus limit h tends to 0, f of a is equal to f dash of a into limit h tends to 0 into h. Now see, if h is going towards 0, that means this expression will tends to 0. 0 into anything will give me 0. Now if h is going towards 0, then this expression will give me only f of a, because h is going to be 0. This is f of a, that means this is going to be some number, some constant term, which is going to be independent of h. So this is going to remain minus f of a. So you can bring this over here. So f of a is equal to f of a. So now you can see this is nothing but this is somewhat this is playing the role of right hand side. When we take the limiting value h tends to 0 at particular point a, or a plus h है, that means this is showing the value of right hand limit, and this is showing the value of function at that point. So right hand limit उस point के बराबर हो गया है. It means if a function is derivable, then it means this is going to be continuous as well. Similar way में हम यहाँ पे माइनस लेके भी कर सकते हैं. So this will result into the f of a minus h. That means left hand limit will be equal to the value of function at that particular point. So we can conclude from this explanation only one thing, कि अगर कोई भी एक function differentiable है, so continuous definitely होगा. बट इसका क्या उल्टा पॉसिबल है, कॉन्वर्स इज इट ट्रू दैट कि अगर कोई फंक्शन कंटिन्यूअस है तो क्या वो डिफरेंशिएबल होगा? हो भी सकता है, नहीं भी हो सकता है. सो दिस इज द डाइसी सिचुएशन दैट इफ अ फंक्शन इज कंटिन्यूअस देन इट मे डिफरेंशिएबल और इट मे नॉट डिफरेंशिएबल, बट इफ अ फंक्शन इज डिफरेंशिएबल दैट मीन्स इट विल बी कंटिन्यूअस. So we'll solve one question on the basis of this, and we'll see, is there any function which is continuous but it is not differentiable? So we'll take the question modulus one question, and we'll try to apply this concept. Okay, now in this question, see, we are having a function modulus of x. Now first we'll check its continuity. So continuity check करने के लिए सबसे पहले we'll define the function. Suppose this is at 0. जब x की वैल्यू या तो 0 है और it is greater than 0, then this is going to be in the positive region. So modulus function is going to remain as it is. But when the value of x is less than 0, then this mod is going to open with the negative sign. So now let's check the continuity. At point x is equal to 0. So how we are supposed to check the continuity? limit x tends to 0 minus f of x. So limit x tends to 0 minus. माइनस का मतलब है कि ये लेफ्ट साइड से अप्रोच कर रहा है एंड इन दिस रीजन फंक्शन इज माइनस एक्स. अगर x 0 की तरफ अप्रोच कर रहा है दिस वैल्यू इज गोइंग टू बी 0. नाउ लिमिट x tends to 0 plus f of x. So limit x tends to 0 plus 0 plus, that means 0 is being approached from the right hand side and in this region function is x. If x tends to 0, this value is going to be 0. Now the third part which we have to see, the value of function, that means f of x is equal to x when, why this is going to be, because I am keeping 0 and 0 you can see I can keep in this region, so this is going to be 0. Now you can see left hand limit, right hand limit and the value of function at the point 0. These three values are equal to each other and hence mod x is continuous at x is equal to 0. This is a continuous function. So now the question is this, whether this is differentiable or not. This is continuous definitely. Now we will check the differentiability of this function. So to check the differentiability, first we are going to find out the left hand derivative. So limit h tends to 0 f of a minus h minus f of a divided by minus h. Now we are checking the differentiability again at which point x is equal to 0. So this is going to be limit h tends to 0 minus f of 0 minus h, this is going to be f of minus h minus f of a minus h. Now see, when h is approaching 0 from this side, in this case the function is minus x. So यहाँ पे फंक्शन क्या चल रहा है, f of x is equal to minus x. Therefore f of minus h. So f of minus h क्या हो जाएगा, minus of minus h. That means this is going to be h. And what is f? In this case the point is 0. So this is also going to be 0. And f of 0 is equal to 0. Now let's substitute. Limit h tends to 0 minus f of minus h is h minus 0 minus h. So this is going to be minus 1. Now we have to check the right hand derivative. Now we'll check right hand derivative. So in right hand derivative, limit h tends to 0 plus f of a plus h minus f of a divided by h. So limit h tends to 0 f of h minus f of 0 upon h. Now you can see 0 is being approached from this side and in this region the function is, our function is x. So therefore f of h is going to be h and f of 0 is going to be 0. So limit h tends to 0 plus f of h is h minus 0 upon h. So this is going to play nothing over here. So h minus 0 is nothing but h only and h will cancel out and this is going to give 1. Now we can clearly see left hand derivative is coming minus 1 and right hand derivative is coming 1. So this both the value are not equal to each other, hence the function is not differentiable. So in this question we have proved the function is continuous but this is not differentiable. So this is the relationship between continuity and differentiability. Again I'll repeat the statement, if the function is differentiable that means this is going to be continuous. लेकिन अगर function continuous है then this is not necessary कि function differentiable होगा या नहीं होगा, कुछ भी हो सकता है. Okay, so we'll solve 2 to 3 problems on the basis of this concept and differentiability. This chapter will be over.
Start.
Okay, now in this question again the function is modulus. So ये चीज हम लोग जब 3-4 क्वेश्चन सॉल्व कर लेंगे तो आपको खुद एक आइडिया मिल जाएगा. जितने भी मॉडुलस वाले फंक्शन होते हैं वो सब कंटिन्यूअस तो होते हैं बट दे आर नॉट डिफरेंशिएबल. सेम वे इसको भी एक थोड़ा हम लोग इसको एक्सप्लेन कर सकते हैं, इसको भी प्रूव करते हैं. सो दिस इज कंटिन्यूअस. कैसे हम चेक करने वाले हैं, देखो दिस इज गोइंग टू बी मॉड और एट 3 दिस इज गोइंग टू चेंज इट्स डेफिनेशन, क्योंकि जब x की वैल्यू 3 से कम होगी सो अंदर वाला टर्म नेगेटिव होगा एंड दैट इज द रीजन दिस इज गोइंग टू ओपन विद द माइनस साइन. बट जब x की वैल्यू इफ इट इज एग्जैक्टली इक्वल टू 3 और इट इज ग्रेटर देन 3, दिस वैल्यू इज गोइंग टू बी पॉजिटिव and this will open as it is. Now check the continuity. The left hand limit, that means limit x tends to 3 f of x. This is going to be right hand limit. So limit x tends to 3 plus 3 को अगर हम राइट साइड से अप्रोच करेंगे, द फंक्शन इज गोइंग टू बी x minus 3 and this will become 0. Now right hand limit x tends to 3 minus f of x. x को 3 को हम अप्रोच कर रहे हैं लेफ्ट हैंड साइड से and the function is this. So limit x tends to 3 minus times of x minus 3 and this is going to be 0. Why? Because if x will tends to 3, this expression is going to be 0. Now f of x is equal to x minus 3 and if because this 3 I can keep in this function, this is solid over here, so f of 3 is also 0. So you can see 0 0 0, that means this function is continuous at x is equal to 3. Now we have to check the differentiability at x is equal to 3. So limit h tends to 0 plus f of x plus a plus h minus f of a and divided by h. So limit h tends to 0 plus, in this case a is what, 3 plus h minus f of 3 divided by h. Now you can see 3 plus h, 3 is over here, if you'll add little bit in it, this is going to lie in this region and the function is x minus 3. तो यहाँ पे फंक्शन क्या हो गया हम लोगों का, f of x is equal to x minus 3. Therefore f of 3 plus h is going to be 3 plus h minus 3 and this will cancel out. So we are getting h in this case. And what is f of 3? So f of 3 will be 0. f of 3, 3 minus 3, 0. Now let's substitute in this case. So limit h tends to 0 plus, this is going to be h. f of 3 is 0 upon h and this will give me 1. Okay. Now right hand derivative, so limit h tends to 0. Okay, this was f of 3 plus, this was right hand derivative. Now we have to go for left hand derivative. So h tends to 0 minus f of a minus h minus f of a divided by h. That means limit h tends to 0 minus f of a की वैल्यू कितनी यहाँ पे 3. So this is going to be 3 minus h f of 3 divided by h. Now see 3 is over here, if you subtract little bit in it, you are going to lie in this region and the function is, in this case function will be f of x is equal to minus x minus 3. We want f of 3 minus h, therefore minus times of 3 minus h minus 3, this will get cancelled out, minus minus plus h and f of 3 will be 0. Just substitute all this value in this expression and let's see हम लोगों को क्या एक्सप्रेशन मिल रहा है. सो लिमिट h टेंड्स टू 0 माइनस f of 3 माइनस h की वैल्यू आई है हम लोगों के पास h माइनस दिस इज गोइंग टू बी 0 डिवाइडेड बाय h. सो दिस विल गिव अस 1. नाउ वी कैन सी okay, now in this case 3 minus h, minus is going to be over there, so this will get cancelled out, this is going to give us plus. Okay, so this is coming 1. Okay, this is left hand derivative, so left hand derivative में नीचे minus होता है, so this is going to be minus, this is going to be minus and so this will come minus. Now we can say right hand derivative and left hand derivative, this both the values are not equal to each other, hence the function is not differentiable. So again in this problem we have seen this function was continuous but this was not differentiable. So overall this is the concept of differentiability and this is how we check the differentiability. Okay, here the chapter gets over. Okay, there are certain properties जो हम लोग एक बार उसको डिफाइन कर देते हैं, थोड़ा सा उसके बारे में देख लेते हैं. Although the concept of continuity and differentiability is finished. So if we are having polynomial function, बस हम लोगों को ये देखना है कि इस तरह के functions कहाँ पे differentiable होते हैं. So polynomial function is differentiable at every point of x. Constant function is also differentiable at every point of r. Trigonometric function and inverse trigonometric function, they are differentiable in their domains. Now exponential function, when a is greater than 0, this is also differentiable at every point x belongs to r. Okay, logarithmic function is differentiable in its domain, so we can say the functions which are listed over here, they are differentiable in their domain. If two functions are either subtracted or we have taken the addition of them or if they are divided, or if we have taken the multiplication. If there are two functions, for example f of x and g of x, the f of x is differentiable and g of x is also differentiable. If we take the addition of this and we are going to get some new function, then this function is also going to be differentiable. If we are going to take subtraction, then also this is going to be differentiable. If we are going to take division, then also this is going to be differentiable. If we are going to take product of them, then also this is going to be differentiable. So as in the starting of the concept, when we are discussing the concept of differentiability, that time only we have discussed that what is the meaning of the differentiation. Differentiation is basically give us the slope of the tangent drawn to the curve at particular point. If we are asked that find out the differentiation at that particular point. So जितने भी curves होते हैं उन curve में कोई भी sharp point नहीं होता है. For example mod x, okay, mod x का curve होता है, यहाँ पे हम we can see we are having sharp point. So at sharp point, if in a function we are having sharp point, so at that particular point function is not differentiable. So this is one thing which can extract from the graph itself. कि अगर आपको graph इस तरीके से बनाया है, if you find any sharp point in the graph, then you can easily conclude that at sharp point in a graph function won't be differentiable. So this is all about the differentiability. Try some questions, definitely you'll be able to solve. If you have studied continuity बहुत अच्छे से, अगर continuity पढ़ा है तो differentiability में कोई problem नहीं होगा, and I can assure you that you can easily solve all the problems. But still, if you find any difficulties, drop the question in the comment box, or you can mail on the email ID as well.